This section is on the library of functions, which is just the functions that you are going to have to memorize, the parent functions, and then we're going to add to that what we call piecewise functions. I'm not going to spend too much time on that, just kind of a little introduction to what piecewise functions are and what that really means. So look at the top of your notes, and you'll see a star on the left, and it says we're going to look at the first function is f of x equals the cube root of x. We've looked at square root of x before. So it says to put it into the graphing calculator and then sketch the graph. What I'd like to do is actually create an XY table for you. So we're going to do it like this, a little differently than maybe you have. F of x equals the cube root of x. So let's start with x being 0. That's always an easy spot to start with. So that would mean f of x is equal to the cube root of 0, which is just 0. So now I'm going to add another column which tells us therefore what point is on the graph. The point 0, 0, 0, 0. See it? Alright? Let's pick 1. Then we would have the cube root of 1, but the cube root of 1 is just 1. So what point is on the graph? The point 1, 1. Now let's think about it a minute. Can we pick negative 1? Can you have the cube root of negative 1? Yes, you can. You can have the cube root of a negative. The cube root of negative 1 is just negative 1 because negative 1 cubed is equal to negative 1. So what point is on the graph? The point negative 1, negative 1. All right? Now our next point, we want to be a number that we can take the cube root of. So I'm not going to pick 2 for x because I can't take the cube root of 2. The next number that I can take the cube root of is 8. So I would have the cube root of 8, which is 2. Therefore, the point 8, 2 is on the graph. And let's do one more. Let's do negative 8. The cube root of negative 8 is negative 2. And so the point negative 8, negative 2 is on the graph. And you could continue in that manner. If you actually put it into your graphing calculator, you can then do table and you can look at these points and see the x and y. But I'm going to just do a sketch of it here based on these points. We have the point 0, 0. We have the point 1, 1. We have the point negative 1, negative 1. And then we have the point 8, 2, which would be somewhere over here, and the point negative 8, negative 2. And what you end up with is a graph that's kind of shaped like this. And I, again, didn't sketch it very well. Look at it in your graphing calculator. It should be nice and smooth, not flat here like I drew it. All right, now let's look at the properties of that graph, the properties of the cube root graph. First off, it says the domain and range are the set of all real numbers. How do we know that? Because I don't have a variable in the denominator. That would give me a restriction. And I don't have a variable under an even root sign. So x can be negative. It's okay. We did it. X is negative 1, x is negative 8, so that's okay. So there are no domain restrictions. So the domain is the set of all real numbers, and the range is the set of all real numbers. Secondly, it says the x-intercept. Well, that's easy to see right there. I have both the x-intercept and the y-intercept. I don't need to really write that. We have that point 0, 0. Third, we have the graph is symmetric with respect to the origin. Therefore, the function is odd. So think about this line, y equals x, right there. That graph, had I drawn it correctly, is symmetric about that line. So that makes it an odd function. We can also show that it's odd algebraically like this. If it's odd, then f of negative x is equal to negative y, or negative f of x. So if I start out with, and I say f of, let's just pick 1. F of 1 equals 1. Oops, that didn't show up. F of 1 equals 1. What does f of negative 1 equal? If it equals the opposite of this, which it does, then it's an odd function. Okay? All right, and fourth, it says it's increasing on the interval, so it's increasing on negative infinity to infinity. Now, again, mine isn't drawn correctly, but on your graphing calculator, you can see there's a gradual increase throughout the entire curve, so it is increasing. It doesn't have a local min or a local max point because it just continues to increase. There's no local min or max. If there was, the graph would have to do something like this or like this, and there's not in order to get a local min or local max. So those are some properties of it. All right, let's look at our second graph. The second one is f of x equals the absolute value of x. And again, I want you to put it in your graphing calculator. Remember how you do that? To get those absolute value bars, you go to second catalog, which is right above the 0. I want you to set the window at -3, 3 for your x values with a scale of 1. And then your y's, I want them to go to -1, 3. Those are your y min and max. And if you put that into your graphing calculator, or even if we don't, we do it with an XY table here, we can figure out some of the points on that graph. So if I start with 0, then f of x would be the absolute value of 0, which is just 0. If I do 1, absolute value of 1 is 1. If I do -1, the absolute value of -1, absolute value of -1 is also 1. 2, whoops, that shouldn't have shown absolute value there. If I pick 2, the absolute value of 2 is 2. If I pick -2, the absolute value of -2 is 2, and so on. You will be able to see in your graphing calculator that it looks like this. We've got the point 1, 1. We have the point -1, 1. And it is not a curve, but it's two straight lines that look like that with nothing down here. All right? So let's take a look at those properties. So the properties, I'm going to abbreviate, of f of x equals absolute value x. Let's see what we've got. First, the domain, going left to right, is all real numbers. However, the range is not, because the range, meaning the how low does it go to how high, it doesn't go below 0, does it? So the range is the set of all y's such that y is greater than or equal to 0. We don't have any negative y's because there's no negative absolute value. Notice I wrote it in set notation there. Secondly, the x and y intercept, both again 0, 0, just like in the last one. Let's look at number 3. It is an even function because it's symmetric about the y-axis, meaning f of -x is equal to f of x. Let's see if it is. Let's take f of 2. F of 2 is 2. F of -2 is also 2. Because these two are equal, therefore it is an even function. All right? Number 4, it has a decreasing section. This part of the graph is decreasing. This part of the graph is increasing. So how would we show that? Well, let's do the decreasing part. It's decreasing on the interval. Where does x begin? It begins at -infinity, and it continues to decrease up to the point 0, not including 0. It's increasing starting at 0 and going to positive infinity. Does it have a local min or max? Yes, it does. It has a local, what is that right there? A local min. So it has a local min point, and the local min is 0 at, remember how we write this, x equals 0. This next one is kind of odd. I don't mean an odd function, but it's an unusual kind of graph, a little bit hard to understand. And that is the function f of x equals, it's written like this, int x. It means integer x. And the definition of that is f of x equals the greatest integer less than or equal to x. And the easiest way to understand it is to do an xy table. So let's do x. F of x equals integer x. And now let's just try some points. If x is negative 1, we're going to start with negative 1. What is the greatest integer that is less than or equal to x? That would be negative 1. Let's do negative 1/2. Remember, integers are whole numbers. So for x, I can pick a rational number, a fraction, or a decimal, but f of x will always be a, quote, whole number, positive or negative. So if I pick a negative 1/2, what is the greatest integer that is less than or equal to x? Think about negative 1/2 on a number line. If I have a number line, and this is 0, and this is negative 1, negative 1/2, the integer that is the closest to negative 1/2, but has to be less than or equal to, is negative 1. All right, negative 1/4, it's also negative 1. When I get to 0, however, the integer that is closest to 0, all right, but it has to be less than or equal to 0, is 0. All right, how about 1/4? Let's look at our number line. If this is 1, here's 1/2, 1/4. What's the greatest integer that is less than or equal to 1/4? That would be 0. How about 1/2? That would also be 0. But once I get up to 1, I get to here, the integer that is less than or equal to 1 is 1, and so on. So it's a very strange little XY table. The graph is even stranger. And I'm going to show you how this works. I'm going to make some pretty big divisions. That's a 1 and that's a 2. 1 and 2. Let's do this as 1. Okay, so it's pretty far apart. So then we have our little halves in between. That's 1/2. That's 1/2. Here's 1/2. Okay, here's 1/2. All right, now let's take a look and look at what this graph actually looks like. So we have the point negative 1, negative 1. That is included. And then we have negative 1/2, negative 1. Okay. We have negative 1/4, negative 1. But if you get up to 0, then it's no longer negative 1. So our graph looks like this, with a solid on that end, but an open circle on this end, because it's not, when x is 0, y is also 0, so that isn't included there. It's not negative 1. So that, I'm talking about this point right here. So if x is 1/4, y is also 0. So that goes up to here, the point 0, 0. And then it goes over, and we have, again, an open circle on the right. And then up here, we have a closed circle, and we have an open circle here. And it's like stairs. And you're going to be able to see it better in your graphing calculator, so let me tell you how to put it in. All right, where do you locate this? It's in your catalog again, so you're going to go y equals, and then you're going to hit second 0, which is catalog, and then you're going to scroll down to the i's, or if you'll notice in the upper right hand corner of the catalog screen, it has a capital A. That means it's in alphabet mode, so you can type an I, which is right above the x squared key. Just type an I and it'll come to the i's, and then scroll down a little shorter and you'll see one that looks like this. Int, open parentheses. Hit that one, hit enter, put in your x, close your parentheses, hit enter. Now go to window, and I want you to set your window like this. -3 for x min, and then 3 for x max, scale of 1, and let's do y as -3, 3 also. Now hit graph and you're going to get a better picture. Now what's different about it on your graphing calculator is it doesn't show the open and closed circles, and that's really important. The left hand circle is always closed and the right hand circle is always open. So it goes like this, meaning here it goes right up to x being 0 and y being 0, but it doesn't equal -1, so you have to put an open circle here and then the closed circle up above it. It's a very odd little graph. Okay, very odd. So let's take a look at some properties of that. First off, the domain and the range is the set of all real numbers. There's no domain restriction. So domain and range is all real numbers. Okay. The y-intercept is 0. So the y-intercept, that is where x is 0, is the point 0, 0. The x-intercept, where does it intersect the x-axis? All along here. It's more than 1. So the x-intercept is on an interval that includes 0 and goes up to 1 but does not include 1. That's very unusual. So that is an interval, not a point, because it's lying right on top of that x-axis there. It's not even or odd, so it's neither even nor odd. And the other thing I wrote here is it has a name. It's called a step function. And I think you can kind of see why, because the graph actually looks like steps without the rise being shown, just the wrong part. If you'll notice on your notes, it says memorize these functions. You've got the constant function, the identity function, the square function, the cube function, square root function, cube root function. Continued on the next page of your notes, you have the reciprocal function, absolute value function, and the greatest integer function. So you need to be able to sketch those parent functions, and you will have a quiz just on whether you have those memorized, just a matching quiz, so make sure you know those. All right, let's take a minute and do something a little different. We're going to look at what we call piecewise functions. And I'm not, like I said, going to spend a lot of time on this, but I want you to see what they look like, because this can happen. So let's look at example 3. It says when functions are defined by more than one equation, they are called piecewise. So it's kind of like saying, well, if x is this, then y is that. But if x is this, then y is that. So it has multiple definitions. So the one that we're going to use is this. F of x is equal to, and notice, there are 3 parts to this. It's equal to negative x plus 1 if x is in between -1 and 1, including -1 but not 1. I'll show you in a minute how this works. So negative x plus 1 is a line. Okay, so it's going to be a line at that point. F of x is equal to 2 if x is equal to 1. And f of x is equal to x squared if x is greater than 1. This is a line, the first one. This is a point, and this is a parabola. So it's going to have different parts to it. You can actually put this into your graphing calculator, but it's such a pain in the neck, I'm not even going to go through that here. It's quite difficult to do. So let's look at part A. It says find f of 0, f of 1, and f of 2. So we're going to use our definition. This is our definition. It's where we defined the function. So f of 0. So let's go up to our definition. Is that greater than 1? No. Is it equal to 1? No. So it must fall here between -1 and 1, but not equal to 1. All right? So what is x going to be? If x is 0, then y is negative x plus 1. So that would be negative x plus 1, negative 0 plus 1, which is just 1. So what point do we have on the graph? We have the point 0, 1. 0, 1. All right, let's try f of 1. Well, that one's easy because our graph says if x is equal to 1, y is 2. So we don't have a choice there. So what point is that? It's the point 1, 2. Now let's do if x is 2. So f of 2. Let's go up to our definition. That would be x being greater than 1, so it's going to be equal to x squared, which would be 2 squared, which is 4. So we have the point 2, 4. Now that is definitely not enough points to do our graph. All right? But I am going to put those points on our graph. So I have the point 0, 1, 0, 1 right there. I have the point 1, 2 right there. And I have the point 2, 4. 2, 1, 2, 3, 4 right there. Now let's look at, that doesn't really help us. So what does this graph really look like? Okay, so let's go back to our definition. The reason I wrote those words is to help you learn to draw this graph. If x is between -1 and 1, but not including 1, then y is the point -x plus 1. So what happens is I have a line that begins at -1, if x is between, here it is, -1 and 1. So I have the point that begins at x is -1, y is 1, and it is a line, sorry, I just told you something wrong. If x is -1, let's refigure that. I told you that that point is not there, sorry. -1, it fits in our first piece of our piecewise function. We would have the opposite of x plus 1 more, which is +1 plus 1, so it's 2. So I meant to draw right here, so ignore that, okay? And that is a line, and that line goes all the way down, but it does not allow x to be 1. It goes right up to 1. So we have this part that goes down like that. I'm kind of exaggerating to show you that, ignoring this. Okay? That's this part right here. Now let's go here. F of x equals 2 if x is 1. So we have the point 1, 2. We have that point right above that hole, so to speak. That's the point 1, 2. I don't know why I was over here. I messed you all up. Ignore some of my earlier ramblings. Okay, now let's look at, so that's this part. We took care of it right there. Okay, the first part is our line, the second part is our point. Now let's look at the parabola. If x is any number greater than 1, but not including 1, we're going to have a parabola. But we're only going to have a part of a parabola. So let's think about that, doing a little XY table for just this part. So let's do x, f of x. Now we know that if x is 1, that y is 2. So I can't use 1, but I could use 1.5, let's say, which is the same thing as 3/2. What would y be? It would be 3/2 squared, or 9/4. I could do 1.125. That would be 9/8. What would y be? 81/16. Alright, I can do 2. X can be 2. Y is 4. X can be 3. Y is 9, etc. If you continue to plot enough of those points, what we end up getting is a parabola, and that parabola goes up to x being 1, and it goes like this. But it can't have x be 1. Does it continue like that on this side? No, but that's why it would, what it would look like if it did, but it can't, because x has to be greater than 1. And now you understand why we're not going to spend a lot of time on these. These can be very confusing. Alright, let's look at B. Determine the domain. Well, all we have to do is look at the definition. What's the smallest x that you can have? X can be greater than 1. X can be equal to 1. X can be -1, but it can't be less than that. So the domain is the set of all x such that x is greater than or equal to -1. All right. Then C says graph. Well, we already did that. I got out of order here a little bit. D says use the graph to find the range. Well, let's look at the range. Notice that all of my graph, this line comes down, it stops right there at y equals 0. Does it ever go down here? Can y be down here? No. So the range of our graph is the set of all y's such that y is greater than 0. Y can't come down into negative land. That was a tough one. You need to practice those.